Alright, this video is going to be on the law of cosines. And just like the law of sines, we use the law of cosines to solve triangles without a right angle. Now, for a law of sines, we had the easy cases for a law of sines when you had angle, side, angle was the information that you were given, or angle, angle, side. And then we had the ambiguous case, which was angle, side, side. And for a law of cosines, we're going to use this if we are given three sides of the triangle, or if we are given two sides of a triangle with an angle in between them. So those are the situations that we are looking for to know that we are doing a law of cosines problem. So again, I'm going to go ahead and draw my triangle. I'm going to do it exactly the same way as when I do law of sines, because it just helps me to kind of keep things the same as much as I can. So the formula is kind of tricky, like it's messy looking, but it's actually not too hard to memorize. So the way that I remember this part, a squared equals b squared plus c squared, is you're kind of doing the alphabet there. And then minus 2bc is just 2 and then the letters that I already used right here, and then the a's on the end match up. And we actually have three versions of the equation depending on which angle you're going to use. So then we have b squared equals a squared plus c squared, so the two letters that I didn't use here, minus 2ac, and then cos of b. And then last, c squared equals a squared plus b squared minus 2ab cos c. So don't try to memorize all three, really just memorize one and know how the pattern works, and then you'll be okay because you'll have all three of them, basically. Okay, so we're going to do two examples, one for each of these situations. So the first example is that we're going to look for when A is 4 and B is 3 and C is 6. And I'll go ahead and label this. So this is a side, side, side case. And when we do law of cosines, it doesn't mean that we can't accidentally find an ambiguous case where there's two possible triangles. It just means we have to be kind of careful about the sides that we're using so that we don't accidentally find one of those two triangle situations and get the wrong one. So the way that we avoid that in law of cosines is we find the biggest angle first. So the biggest angle corresponds to the biggest side, so 6 is the one we're going to use first, which means first we're going to solve for angle C. So I'm going to say 6 squared equals 4 squared plus 3 squared minus 2 times 4 times 3 cos C. So 6 squared is 36. 4 squared plus 3 squared would be 16 plus 9, that's 25. 2 times 4 times 3 is 24. So now I can't combine the 25 minus the 24, which students always want to do, and I can't do that because 24 is a coefficient for C. These things are being multiplied. But I can go ahead and minus the 25 over the other side to make the problem a little bit more simple. So 11 equals negative 24 cos C. And then I can go ahead and divide by negative 24. So I've got this fraction equals cos C. So if I want to solve for angle C, I just need to do cos inverse of that fraction. And typically these problems end up dealing with a lot of nasty decimals. So I'm going to go ahead and actually let this be the terrible decimal. Well, I guess it's not that terrible. But I'm going to go ahead and let it be the decimal so we can practice how to plug this in the event that we really truly did have a decimal that could not be written as a fraction. which I guess in this circumstance wouldn't really happen, but it will in the other situations, so we're going to practice anyway. So cos inverse is second cos, and then I know that your calculator has an option where you can go up and grab the decimal, but that, I believe, rounds it, and I don't want the rounded decimal. So the way we're going to pull this decimal down and use the whole number is we're going to hit second, and then this negative sign down here, and it writes the letters ANS, which means it took the previous answer and it plugged it in, and it used all of the numbers. So that's good, that's what we want. Alright, 117.3 degrees. Now all these rounding issues, if you're doing to one decimal place, you don't technically probably need to store the whole number, but let's say you have a teacher at some point who wants you to do like 4 decimal places, then you would definitely need to keep all of the numbers there. So that's why I'm just going to show you guys how to store these numbers and practice this, is just in case I make you, show me more decimals. So since this is angle C, I'm going to store it. So hit store, alpha C. So I'm going to store this as C because I'm going to use it in a little bit. Okay, so I have angle C. Now I need to go back and find the next biggest angle, which in this problem would be angle A. So now I'm going to say 4 squared equals b squared plus c squared minus 2 times b times c cos of A. And so we're going to do the same thing again. Now you could be doing 9 plus 36 is 45. I thought that I could multitask, but I can't. 6 times 6 is 36. Now, you could be doing law of sines here, and some students will like to do that, but you really have to be careful to avoid the ambiguous case with law of sines, so just watch out for that. Okay, minus 45, minus 45. So 16 minus 45 is negative 29. So negative 29 equals negative 36 cos A. And then I'll go ahead and divide that. So negative 29 divided by negative 36 gives me that decimal. So 0.805 equals cos A. And so then I'm going to do cos inverse of this decimal. And I get that angle A is approximately 36.3 degrees. Okay. So now I just need to find angle B, and I can say 180 minus the answer that I just got for angle A, minus C, alpha C, and that means that B is 26.4 degrees. So again, rounding to one decimal place with the storing of the numbers didn't make any difference really, but in the event that I had you do more decimals, it would have actually been a problem. Okay, the next example that we're going to do, actually, let me go back to this. I wanted to talk about the law of sines. So let's say you wanted to use the law of sines to do angle A, then you would have used the information that you already had given. So you already had solved for angle C, right? So then you would have done 6 over sine of C, I'm going to put C there because we stored that number, equals 3 over sine of B. And if you had done that, C and 3 and 6 is angle side side. And you would have been given the ambiguous case. So when you solved this, you could have been solving for the right triangle, or you could have been solving for the first triangle when really the second answer was the right one. And so that's why you have to be real careful if you use the law of sines to make sure that you're actually finding the correct triangle. And because that's the case, I usually encourage students, if they're doing a law of cosines problem, just finish the whole problem with law of cosines, because most students don't think of the ambiguous case. When they're trying to finish solving a law of cosines problem, they're just not thinking about it. So just watch out for that, because if we had used law of sines here, we would have been doing the ambiguous case, and we would have had to see which of the two answers really was right. Okay, So the second example, I'm going to say that A is 2 and B is 3, and I'm going to give you that gamma, I'm going to do Greek letters this time, and I'm going to give you as 58 degrees. Okay, so on this one, since we have, actually let's go ahead and draw our picture. So alpha goes with A, and beta goes with B, and gamma goes with C. So I have to solve for side C first. So I'm going to say C squared equals A squared plus B squared minus 2 times A times B cos of 58 degrees. Okay, now this is the variable I'm solving for, and it's already alone, so I'm going to go ahead and plug all this stuff into my calculator. So 2 squared plus 3 squared minus 2 times 2 times 3 times cos 58. So I've got C squared is 6.6409. And now to figure out what the value for C is, I just need to square root that. And I'm lazy, I usually do it to the 0.5 because 1/2 is still a square root. If that makes you uncomfortable, for sure you can do the actual square root of that. So this would be approximately 2.6. And I did not do this on the previous problem, but I really am going to be nitpicky about whether or not you put your units there. So I'm going to go ahead and put a unit on this example. So I'm going to say that C is 2.6 centimeters, and on this problem it actually is very important that we store this number because we're going to use it, and it will make a difference. So I'm going to go ahead and store this as C because it's side C that I'm talking about. I'm going to write a note to myself that I stored that as C. Okay, so I've got C now as 2.6, and then like I said before, we always go for the biggest angles first if we can. So 3 is the biggest side, so that means that's the next angle. Angle beta is the next one I'm going to solve for. So B squared equals A squared plus C squared minus 2 times A times C cos beta. And I'm putting this here just because I think that might help us remember that we use that stored number right there. Okay, now as we do this problem, we're going to be storing even more numbers, so just stick with me here, we'll be okay. So 3 squared is 9. And then what we have to do next is we have to put these numbers together because we can, but I can't subtract these because this stuff all right here is actually a coefficient for cos. So I'm going to ignore this part for right now, and I'm just going to do 2 squared, where's the squared, plus C squared. So that gives me the decimal 10.6409, and I'm going to go ahead and store that as D right here. So I'm going to hit store that as D. Okay. Next I have negative 2 times C. So negative 2 times 2 times C. And that gives me negative 10.308. And that's the number that's being multiplied by cos B. I'm going to go ahead and store this as E. Okay, and this is the part that gets a little tricky for students when they store it, is if you notice I used the negative when I stored it as E. So basically the equation that I have right now is 9 equals D plus E. I'm writing plus because I stored E as like the whole negative number times cos beta. Alright, so this is truly the problem that I'm doing now. Okay, so now I'm just going to go ahead and subtract D from each side. So minus D minus D. So I've got 9 subtract D. Okay, and leave that number on your screen. We're not actually going to have to store that. And then we'll go ahead and divide by the value for E that we had. So I've got that number, I'm dividing it by E. And so now I have this decimal point 159 equals cos beta. And now I can go ahead and just do cos inverse. So cos inverse of that decimal, and I have beta is approximately 80.8 degrees. Okay, so now I've got that. I have the original angle that I had, so I can go ahead and get my third angle. So 180 minus the angle I just got, minus 58 from the beginning, and that tells us that angle alpha should be 41.2 degrees. And there are the three missing pieces of information.